Hello, everyone. This is Professor Ma, and this is the section about the graph of second degree equation. Second degree, of course, refers to x squared. And let's start out with a typical x squared minus x squared. Let's plot that. We're going to make the graphs by plotting points, and I'm going to select x from -4 to 4, and we're going to square the x, and afterwards make a minus. In other words, the answer for the y's are always going to be negative because the squaring is positive, and then the minus goes on top of that, makes a minus. It's a minus 16, minus 9, minus 4, squaring the numbers and make a minus. Same thing for the negative x's, exactly the same thing happens. And this table is symmetric, up and down. So when we graph it, we get a symmetric graph. So from the table, we get these points. 4 minus 16 is right here, 3 minus 9 is right here. And if I plot them, and finally -4 minus 16 right there. Okay. And so this is different from first degree, which we did last time. It's a straight line. And so the second degree is a curve, looks like these, and these curves are called parabolas. So this is a typical parabolas. And in physics, the parabola is the path of thrown objects, and that's being pulled back by the gravitation, because the reason that the path, this describes the path because the law for the gravitational force is the second degree. Therefore, the object trajectory follow a parabolic path. And the parabola can be skinnier, fatter, or upside down. Okay, you can imagine that's a thrown ball down in the southern hemisphere, okay, in Australia. So that will be the path in our perspective. And since they're parabolas, though, we therefore know quite a bit about them. So basically what I meant by is that we're all kind of familiar with them, that they all have a tip. And the tip sits on the center line. Okay, and the tips are called vertices. Okay, so the graph these, therefore, to graph one of these parabolic path of an object being thrown, the strategy therefore is, of course, plot the vertex. And after we plot the vertex, then we try to figure out how fat or how skinny the parabola is, which way it faces. First of all, once we get a vertex, we want to figure out which way the parabola faces, and then how big it is, opens or skinny. Okay, and so this is what we're going to do to graph parabolas. And to make it easy, the vertex happens at x coordinate equal to -b/2a, and this actually is the front part of the quadratic formula. If I continue with b squared minus 4ac, blah, blah, blah. This is quadratic formula. But if I dump this part, pretend this part is 0, then the front fractions is gives the tip of the parabola for the x coordinate of it. So here is another fact we need. Remember, we have to decide whether the thing goes up or goes down. Well, if the number in the front of x squared is positive, that means x becomes bigger, bigger, the y becomes bigger, bigger, and higher, so it goes up. But if it's negative, the x becomes bigger, bigger, y becomes more and more negative, so it goes down. So that's how we determine it goes up or go down. And that's a vertex. And so now we have a strategy of plotting parabolas. So to graph a parabola, we find the vertex, okay, and then we figure out which way it goes. Then we find another point of the away from the vertex. Okay, so let's do this as an example. Okay, find the vertex, and this is the x coordinate for the vertex. So make sure you be careful with the minus. So this comes on the minus b over a to a, and usually if there's some things doesn't come out right, it's because a lot of times because the very beginning the vertex incorrect due to the negative sign. So anyway, this case x is 2. You plug these 2 into the equations. Why? Well, because I want to find out what y is. Okay, and so I know what the position of the point is. So plug into, you get minus 16. So the vertex 2 minus 16. So I can say, oh, okay, I know where that is. 2 to the x minus 16 is way down here. And the parabola goes up. Okay, so from there, I got a lot of information. So now, so I know the point vertex here. Yeah, I know it goes up. Then the second thing we're going to do is want to find another location that's off besides these points. Where's location that's easiest if possible? Well, put x equal to 0. Okay, why? Because that's easy to evaluate. If I put x to 0, I can basically read out y is equal to minus 12. So just eyeball 0 minus 12. I get a y-intercept. And there we go. There we have the graph of parabola. Here's the reason. Here's a tip. And I got one point on this side. Therefore, since it's a parabola is symmetric, the other point must be on this side is also on the parabola. Once I know these 3 points, these tips, triangular tips, now I know how wide the parabola is open. I can trace them. Okay, that's 0 minus 12. From here to here is 2. And so go over another 2 is 4. 4 what? Minus 12. Y is still the same thing. So therefore on the other side, I get that, and voila, that's parabola. And then the last couple of things we need to complete is to find out what the x-intercepts are. And that again, set y 0. That's x equal to something, y has to be 0. So you take the 0 for the y, you put in y, you solve for the x. And there you are. So this is how we graph parabola. It's very simple. Okay, but you need to remember its formula to locate the tip, then figure out it goes up or down. And once you have that image in your head, you need another point on that imaginary parabola precisely. So you can plot the mirror image on the other side of the tip. And there's a more complete trace of the parabola. Here's an example how we use these. A good example is that we locate where the tip is. The tip, notice on the graph of parabola here on this tip is y is equal to minus 16 is the lowest point on the parabola. Okay. Later on we'll call that minimum. Okay, and that has significance. So in this problem, we're going to have a parabola that's upside down. We're going to locate the tip on top, the highest point, which in this case is the highest revenue that we're going to get. So in other words, this problem is a problem of maximizing intakes, revenues. Okay, and the $8 chicken can sell 120. But if I jack out the price by 50 cents, less customer will come, so 4 chickens will be sold less. So if I go up to 850, 4 less will be 116, only 116 chickens left. But that's okay because each one I give 15 more cents, so my intake actually is a lot more. I mean, think of the revenue coming in is a lot more. So basically, the trick over here is to set X to be how many times you want to increase the 50 cents price bar. If you increase it once, it goes up by 50 cents. If you increase it twice, it goes up by $1. If you increase X is 4, that means you're going to increase the price up to $10. 8 to 10, that is increased by $4. Okay. So this is the price, $8 plus how many times you're going to increase by. That's X divided by 2. So, okay, check that this formula. Okay. So X is the number of times you're going to do it. But then for each time you increase the price, 4 less customers will buy. That means X, if you do X time, you're going to have 4 times X less customers. So the customer will be 120 minus the 4 times X. And what's the total revenue? Okay, what's the total amount of money you're taking? Well, it's how much it costs for per chicken times how many chicken will be sold at that price, right? The price per chicken times how many chickens are sold. So in other words, the revenue is a product of these two things. And this is the second degree equations. And this is how much money you take in, and actually depends on how many times that you're going to raise the price by the X being squared. And if I plot this, it's a parabola, since it's a minus sign, it's upside down parabola. I can find the tip of this parabola. That means remember the tip in this case will be the highest revenue, the most amount of money I can take in. I want to know what that X is supposed to be. And so I find the vertex is minus B over 2A. So in other words, X is 7. That means you're going to increase the price by 7 times. Okay, which means original was $8, 7 times. So that is $3.50 increase. So you going to sell the chickens at $11.50 per chicken. Yeah, that's what Pollo Loco doing now these days. It's up. And now, but of course you sell a lot less number of chickens, but you find out the revenue is 158. Okay, so 1150 per chickens. You're going to sell 92 chicken to get $1,058, and that will be the most amount of money you will take in. Okay, so this is an example of application of second degree equation and the vertices. Okay, do the homework, and that's it. Bye-bye. Stop the video. And